Here's number 15. Again, the goal is to determine whether this converges and diverges, and we have to figure out what tests we're going to use. You think it diverges?
I think you're wrong.
I
I think
think
you're very wrong
Really
just because root n is like
Well, when you
n
say
to the 1/2.
So if I made a little note to myself, I might say n root n over n squared, which is essentially what this is looking like. Root n to the 1/2 over root over n squared is
Oh, that's okay.
essentially 1
Subtracted
over
from-
n to the 3/2,
I like
essentially.
subtracted from- I converted.
which is, and 3/2 is greater than 1. I think this is going to be a limit comparison test, and I think n over 1 over n to the 3/2 is our comparison.
Yeah.
So let's say, let's compare this, compare to sigma 1 over n to the 3/2, which is a known,
Get off me, freak.
I'm glad we got that on the recording, a known convergent series. Why? Because it's a p-series. It's a p-series with p greater than 1. Are we okay with that start?
Yeah.
So now let's write out the limit part of the limit comparison test. The limit as n approaches infinity of root n over n squared plus 1 multiplied by
N to the 3/2.
n to the 3/2 over 1, the reciprocal of the comparing ones. And when we do that, we get the limit as n approaches infinity of n squared over n squared plus 1. Double check my algebra there. This is n to the 1/2 times n to the 3/2 n squared. And that's equal to, as n goes to infinity, that's equal to 1, which is finite and positive. Therefore,
Converted
By
by limit comparison test.
okay, and again, whatever said there, that is converges, right, by limit comparison test. That's pretty good, isn't it?
I like it.
I like it too.
I'm a personal fan.
All right. So let's close off that recording.